Hi y'all, it's Chris DeLeon, TA for LMC 6310, the Computer's Expressive Medium at Georgia Tech and Digital Media Program. This is a continuation of my video series of basically adapting the content that I cover in lab for introducing programming, prototyping of real-time interactive graphical systems for the use of projects in this class. And again, to emphasize in the write-ups, but the class isn't really about programming for its own sake. It's about theory, using digital media for expressive purposes, but the basic skill sets that we use definitely involve programming, and so that's what these videos are about. Now, the previous video, if you've been following along, I spent a good amount of time showing how to make a mouse trail dynamically, so you could leave a trail from the mouse. And then I kind of at the last minute also showed how to load an image and how to load a font. And I realized that, those are two very kind of isolated concepts, that there's no reason for those to be packed all together to make a video a certain length. So hopefully this video will be a bit shorter. I'm just going to today specifically cover how to save out the screen, which is a handy thing for a drawing application or even just for debugging purposes to be able to print out frames from your program, as well as an example of how to add a title screen, which is, there's no like built-in high-level concept of a title screen. It's just going to be a matter of how we use a Boolean variable to redirect our functionality within the program. So without further ado, let's get started on our basic application processing at all times. And again, you can get this program from processing.org in case you're joining us late. It's free. Just you have the option to make a donation to the processing organization. No need to do that yet. Every program has setup and draw, which I'm going to continue to reiterate every single video probably. Setup gets run once when the program starts. Draw is called every single frame, so constantly, effectively, continuously. Size is a function we almost always have at the start of a processing application that we use to set the video size, and I think we've decided before that when I press play, 640 by 440 should give me a window about this size, which fits nicely under my video. So it's of course down here relative to me on the screen. And we want to be able to, first of all, let's just make it so we can draw some stuff. We'll put remember the 4 parameters for rectangle are the width, or I'm sorry, the X position, number of pixels from the left side of the screen, Y position, number of pixels from the top. That defines the top left corner of the rectangle, and then it's the width and height are the next two variables. So if we make 150 pixel wide, 50 pixels tall, let's see, we keep randomly changing the color, brightness, fill value, random, 255. Let's see what that does for us. This should give us some strobing square. There we go. And as I've explained before in the other videos, the reason you see a smudge is because we're never clearing the buffer. If it was drawn once, it stays drawn. It's not having to redraw it. And all we're doing here is smudging it around. I just want to create a way that we could save out an image. So we have now a program that can create a picture, and to save that picture out is actually really easy for us to do. First of all, we're going to have to catch a key press, which I'm not sure we've done before in these videos. So this might in itself be worth covering for its own sake. But whenever you press a key in processing, it's going to call the key pressed function. Here we have void key pressed. And inside there we can filter on the key by checking which key character it matches. So if I wanted to catch the space bar, here I could put, you can tell I've been juggling other programming images. We could say spacebar was pressed. And between these two single quotes, those are the ones underneath the double quotes, between the two single quotes, I just press spacebar to show if the key is space, as opposed to if the key is, I don't know, R. R key was pressed. And notice too that even if none of those conditions are met, some key was pressed. Void key press will still be called, but as a matter of if one of our if statements catches a match on the key, then we might want to do something special. So if I just press play, remember that the print line statements don't show up in our program over here. Our print line statements show up in the console log, the black space underneath our processing application. So with the processing application highlighted, I'm going to press O key, and you'll see some key was pressed, P, some key was pressed. When I press spacebar, it still gets to the some key was pressed, then it goes down to the next line and checks, was it space? It is, so it says spacebar was pressed. Press R, some key was pressed, it skips the space condition because it's not the space key, but it is the R key, so it says R key was pressed. And in this way, we can handle key presses to save out the image when we press a particular key. Now I do want to address, even though it's a slight tangent, that while we're on the topic, those work for keys that have letters, that have characters easily assigned to it, so like the number 4, you could map this way. But let's say you want to check the left arrow, and you're wondering, okay, how do I check for that? In those cases, instead of using key, we have to use key code, and then we spell it all in capitals. So here I'd say left arrow key was pressed, and I believe it also works for things like tab. Yep. We pressed tab, and of course, as always, these could say anything. These could say pigs in a blanket or elephants in a safari or whatever. When I press tab, some key was pressed, we pressed tab. Space, some key was pressed, space bar was pressed. Left arrow was pressed when I press the left arrow down on my keyboard. And again, it's an important distinction to notice that for things that have a character on them, we use the key to check, in contrast to for things that do not have a character. Left arrow, up, down, right, tab, probably enter or return. Instead, we have to use an all capitals stand-in for it, which is preset up in processing, and match it against key code instead of key. I'll also point out that we're using the equals equals here. That is a comparison. That's checking to see, is it true that these two values are the same? Remember that in programming, a single equal sign is for assignment, changes the value in the variable. Two equal signs compares and checks, are the two values on both sides equal, and if so, returns true, which would then go between the braces for the if statement. So, now that we've got some of that out of the way, we can go ahead and make it so when we press S, we want to save the image. I'm going to clear out some of these print line statements. And all we have to do for this really is say save frame. Now if you haven't yet, this would be a good time to save your project because it's going to want a directory to save your file into. So I'm going to go it's Command S or Control S on Windows. So of course you can go to File, Save, and that's where I saw the Command S is the shortcut for it. From there I can create the directory for it, and let's say save image. Okay, and so now if I run the program, move my rectangle box around to smudge, and we could draw anything we want. We could write routines that put crazy lines everywhere. In fact, we're doing just that. Float, previous angle. Well, I don't want to get too crazy. All right, so every single frame, we're going to draw, let's see, a line that's going to go from, let's say, a random position to a random position. How's that sound? So a random position horizontally on the screen and a random position vertically to, actually let's make all of them meet in the middle, to the middle of the screen, halfway through the width, halfway through the height. So every single frame, we should now see a random line being drawn as well. There they go. See, it's picking a random coordinate up to the size of the width of the screen. Width and height get filled in automatically based on our size and setup. And then the width divided by 2, height divided by 2 give us the center of the screen. And you see here what I mean by the sort of residual effect of the buffer. We can kind of erase or cover up the previously drawn lines, and once we move our rectangle away, they begin to rapidly accumulate again. But so now we have a drawing application in some sense, and we press S, it saved it. Now you don't have any evidence yet that it saved it, because where it saved it did it silently for us. And where we have to go for that is we have to check the directory that our project is in. And in case you weren't paying attention to that, we can go to Save As, and look carefully here at what's your path. So here on Mac, by default, I have documents, that's my documents, so the equivalent in Windows, processing folder, and inside there are all the sketches. I just need to navigate to that in my system. So documents, processing. Let me move this out of my camera's way. I realize that can be a bit of a bother. Okay, and now what do we call this? It's 13, by default it puts the date in there, which is kind of handy. But that's also why I put at the end of it, save image. You can see I put the last part there so it's easy for me to scroll down and see it. Aha! And here we have a TIFF file in our directory, which is a screenshot of the application as it appeared the moment I pressed the S key. Now you might be wondering, TIFF. Who really uses TIFFs anymore? It's 2013, and I'm glad you asked, because we can specifically name the file if we'd like. We could say nicer format, .jpeg, save. I'm going to press play. When I press the S key, if I move this out of the way, you'll see it saved nicer format.jpg. I can click on this and we'll see the image. And if I press S again, it's actually going to overwrite the previous image because it's keeping that same file name right there. See, I can keep pressing S and updating the image on the computer. See how the thumbnail changes when I press S. Now, of course, it would be nice for your program to acknowledge somehow to give the user feedback that they correctly saved. You could at the very least print out a debug value with println, so it shows up in the console. You might have a beep emitted using the minimum sound library or something. But for starters, this is all that's necessary really to save the image. Now you could do fancier things. And so let's say, okay, I want to be able to save a whole series of images. And by the way, as to the formats provided or that supported, JPG, GIF, I believe. We can find out. BMP, I think. They're well documented in the processing.org reference site, and so you can check that out. It looks like GIF saved fine as well. And you kind of experiment with different formats. They all have different trade-offs about file size and lossiness for different types of images. But the extension is being used as a clue by save frame to figure out what type of format to save the image as. Well, let's say we want to save a whole series of frames. I'm going to create a global integer here. Global just in that it's not within the scope of a function, so it persists between any given function's calls. And just a reminder, so setup, called when the program starts, draw, called every frame. Key pressed is also specially hooked into processing, so it gets called every time any key is pressed, even if it's a key we're not doing anything with. And let's say image save num, started at 0, and now we're going to splice together a string here using a pluses to concatenate the text. So now it's going to say anim frame, then it's going to have a number, which will start off at 0. It's going to put .jpg at the end of it. And it's going to concatenate it together into a string, so it'll be like anim frame 0.jpg, anim frame 1.jpg. And then I'm going to increase it. Remember that plus plus is the same as saying identical to plus equals 1, which is identical to, sorry if I point this out too much, image save equals image save num plus 1, which of course means to take the value that was in that variable, add 1 to it, and then assign it left to update the value in memory, so that each time we save, it's going to increase this number after using it. And we'll see that here when I press play. Okay, so now watch over here in the directory when I press the S key. Watch for it and press the S key now. Enter frame 0, 1, 2, when I press S, 3, 4, move it around a bit more, 5, 6, 7. And of course, we could set this up on a timer. We could set this up with a decrementing value in the main loop if we wanted to have it automatically export, say, a frame every second or something. That's stuff we could write code to do. And here, if we scroll through these, you'll see that we have a whole little animated series of what our program has drawn by just increasing that number. And of course, unless we change the number, the start count or something, it'll begin to overwrite these when the program starts. It's actually something we could sidestep if we had it automatically try to load image files to figure out which ones exist, and there's ways around that. But for now, that's how we save an image for our program. Now let's say we want to have a title screen, which is a good way to add a little bit of class to your program. We showed like last time how to use nicer fonts and things. That would be a good thing to do in tandem with having a title screen. Well, for that, I'm going to move my global variables up to the top, just so they're not floating between functions where they're hard to figure out, hard to notice which ones are there. For this, we're going to need a Boolean value. We're going to call this isOnTitleScreen. And we're started off as true. Okay? Now, all we need to do now is redirect our program in the draw loop based on whether or not we're currently in the title screen. So if we're on the title screen, we're going to draw things differently. Okay, let's do a black background, and let's have some text on the screen that says press space to begin. And I will suggest that it is extremely, extremely important to have a textual clue spelled out on the title screen of what they need to do to proceed, if they need to click, if they need to press spacebar. Don't make them guess. Please don't make me as the TA guess. Always make it clear. These are not the days of where you've got a gamepad and you know you can assume to press start, or an arcade machine where you just have to push the button. There's 104 buttons on your keyboard-ish, plus your mouse's functionality. Maybe they think they're waiting for a load or something. Tell them how to get past it. Now there's two ways we could handle making the rest of the program not happen while we're on the title screen. One approach is we could put an else statement around the rest of the program so that while we're on the title screen, it does this. Otherwise, meaning if we're not on the title screen, it'll do all the rest of this code. However, and this works perfectly fine. You could totally do this, not the end of the world at all. Remember, else just means if the if condition was false, so we're not on the title screen, then we're going to show this other stuff. What I prefer to do, because that indents us one layer deeper, kind of needlessly, since the whole rest of the function does those deals, is we can just have a return here, and return is going to short circuit the draw function, so it will not reach the code below it if we entered this if. So it's going to draw the background, it's going to redraw the space. We could even draw an ellipse at the mouse, just to show that we're still doing live updating content on the screen. Mouse X, mouse Y. I don't want to create the impression that it's just a static image. Okay, So if we're on the title screen, then it's going to clear the background of black. It's going to print some text. It's going to draw an ellipse under the mouse, and it's going to stop the draw function before it reaches the rest. We still need a way to escape the title screen though, and so we're going to go back to void key pressed. We're going to say if key equals space. Remember, that's just how we're going to check for spacebar. Then we're going to set that to false. So see how this works? We just have a Boolean that keeps track of true or false. So remember, integers keep track of numbers, floats have decimal points, strings are list of characters. A Boolean can only be true or false. And we could, and historically many programmers have, we could just use an integer here that when it's set to 1 means we're on the title screen, when it's set to 0, we're not. That's really, in fact, what's going on under the hood here, but using a Boolean helps communicate to us as the programmer later, or as our friends if we share the code with them, that this value is distinctly meant as a true false and not as a numerical enumeration or an integer to keep count of something. So we're just default to true. While it's true, it's going to draw the background, a text clue for how to start the program. And this is, remember, we could set nicer fonts and things instead if we wanted to, using our skills we covered in the previous video. Drawing an ellipse at the mouse just to show that the program is live updating, and then it's going to skip back into the program. Or it's going to skip the rest of the code in the draw function. Once you press the spacebar, it's going to set that flag to false, which means that this if statement will be skipped. So next time when the future when draw gets called, it's going to bypass all of that block and instead going to do the program you had previously. So I'm going to press play. You see it? So there's our title screen mode, and sure enough, there's our text like we have there. It's clear, but you can tell we're using this background 0 call because it's not smearing the circle like we do in the program. But once I press space, then it starts to draw what we saw before. Notice too, for example, that it didn't white out our screen. It kept the title screen information there when I pressed space because we never told it to erase that press space to begin. It's still residual on the buffer like our draw things, and it maybe makes these lines look not as nice. So we could even have a transition here that as we press that, we could also do a background 255 to erase the screen the way it looked. So we're starting with a white buffer, getting rid of that text in the circle. Now we go straight into the program when we exit the title screen. If we wanted a function to go back to the title screen, we could, of course, check a different key. Let's try this. I'm not positive that escape works. It looks like it might. Let's find out. And if I press escape, it might actually just bail on the application. We'll see. Press space, so we're here. Yeah, escape just bailed the application. Wonder if backspace. I might not actually have it on my Mac because I have a delete button instead. Backspace, yes, there we go. Which on a Mac actually maps to the delete key because that's where backspace is on a PC. But so now we have a way to get to and from the menus. And we could, for example, also have this toggle if we wanted. So if we're on the title screen, then we're going to leave the title screen, else we will return to the title screen. See how that logic works? If we're on the title screen when we press space, we're going to leave it, else, otherwise, we're going to go to the title screen. And there's another little anomaly that you're witnessing here that I want to call attention to. Right now, notice the press space begins as a bright white. Now I'm going to toggle back to it. It's a gray, darker gray, bright white, very dark gray. What's happening is we have this random fill here that's changing the brightness. And remember that value is persistent until fill gets updated again. So really when we go back to the title screen, we should make sure that our fill value is left at bright white, or is returned rather to bright white. And sure enough, here's our program where we have a title screen we can get to and from. And the program sort of lives past the title screen in some conceptual sense. It's worth noting too, when I press the S key, let me get rid of my old frames because it replaced that, but you couldn't necessarily see it from what we were doing. I'm going to delete those, delete that TIFF as well. Okay, when I press the S key, still saves the pictures, but I can also press S key on the title screen. See, which is a little maybe disorienting or unnecessary. And so if we wanted to make S key not work on the title screen, you know what we do, right? We would take our is on title screen, we would check and see if it's false. Then we allow the save frame and incrementing to happen. Another thing we could do, so we have here two nestled ifs, if this and also that. This is a good place for us to use the ampersands, which I like to read as and also. and a single ampersand means something different in programming than two. It has to do with binary math, or Boolean logic, or Boolean, yeah. And so here are two ampersands. If the key pressed is S, and also we are not on the title screen, is on the title screen is false, then it does those things in terms of saving the image and incrementing the frame. So I'm going to delete these as evidence. When I press S now, it won't save the file. Look over here in the folder, no saved file. I press spacebar to start. I can press S now to save the images. Spacebar takes me back to the title screen. I press S some more. Still won't save. I go back, and it continues saving more images. And so there we go. Covered some essential little skills that hopefully will help you out in making your programs and your applications for class or for otherwise. The conceptual background for how to make a title screen, as well as how to save images with an incrementing counter. And in the process, also covered some keyboard input, which was not maybe originally the plan, but I realized we had to cover to get there, so good on us. A last note, too, might be to suggest that for adding instructions to your program, let's bump this line down, press S key to save image. It's good to have your program self-documenting, to have your application itself include whatever instructions the interactor is going to need to know, because you can't always count on your program being experienced, either in the context of you there to explain it, or even embedded on a particular web page if it was a web-based application. Oftentimes, programs wind up lives of their own, running elsewhere in the world, downloaded as source, and so on. And so it's really helpful to have your instructions there on your title screen. And I think that's one of the useful things to do with the title screen is to have it double as sort of mini instructions to make sure that the user is set up with a clear idea of what they can do in your application and how they're going to do it. And that's just adding extra text to the screen. So that's Chris DeLeon for LMC 6310. Little short video here, and hopefully it's been helpful. I'll have another one up coming for you soon. We're going to start moving into APIs very soon. Thanks so much. Bye-bye.